Assalamu alaikum students, this is Farba Batul, your O-level computer science instructor, and welcome to another video. In this video, we will be doing example number 4 of Boolean logic. We are already done with example number 1, 2, 3. If you want to see the videos, go ahead and watch them on my channel. Okay, so let's quickly start with example number 4. The example says that look at the two truth tables below. Here are two truth tables that I have. In each case, produce a logic expression. It's very important that you have to produce a logic expression from the truth tables and the logic circuit. So if I talk about this problem, in this problem, what you have to do, you are given the truth table. With the help of truth table, first you will produce a logic expression, and then by using the logic expression, you can produce a logic circuit. And if you don't know how to produce a logic circuit out of logic expression, you can see my previous video, example number 3. Okay, now quickly start with table number 1. First of all, I'm removing this table number 2 for you, and let's only consider the first table, this one, for working. Okay, so this is part A. According to this table, first of all, whenever you want to make a logic expression out of a truth table, you have to consider only those rows that has a value 1 or the output 1. You will see the column of your output, and where the values are 1, you will only be considering those rows. There is no need to consider this one, no need to consider this one, no need to consider this one. Why? Because all of these are zeros. The output is 0. Only this row will be considered. Why? Because here the output is 1. So once you see that, after that, you will see the values of your inputs, A and B. There are only two input values. So remember that your expression will only be having A, B. Now let's see that what are the gates that will be involved. So for A, since the value is 1, so you will keep A as it is. But for B, you have a value 0. Whenever there is a value 0 for any input, it becomes not B. For the values of 1, keep the input as it is. Like for A, if it is 1, keep it A. For the inputs that have value 0, you will not write 0 in your logic expression. Rather, you will make it not B. So now, always, you have to connect both of these inputs with an AND gate. The two inputs that are in one row will be connected through an AND gate. This is something you can say that it is a standard, that you cannot change it. It's the law that both of these inputs in one row will be connected through an AND gate. Only what you have to see is either you have to keep the input as it is, like AB, or you have to make it not B. And I have already mentioned that if the inputs have value 1, you will keep it as it is. But if your input has a value 0, you will say it is not A. Or in this case, since B has a value 0, so you have kept it not B. So this is a simple thing that you need to learn about making expressions, logic expressions out of truth tables. First thing, consider only those rows with output 1. Number 2, in one row, if input value is 1, keep it as it is in your logic expression. But this is very important. If input value is 0 in the same row, you have to write it with a not. Is 0, put a not, with it, with the input value. Like if it is, in our case, it becomes not B, since B has a 0 value in the row that we are considering. And here the example is the way you have considered A. And the final thing that you need to know is join the inputs with an AND gate. Inputs with AND gate in a row. When you are working with a single row, just join their inputs with AND gate. Okay, this is what we have done with this table. Now quickly moving towards, this is your logic expression.
Miss Young, please come to the office. Thank you.
This is your logic expression of the truth table. Now quickly making the logic circuit. Okay, in the logic circuit, you have to see the inputs first. The first wire is A, the other wire is B. You have two input values, but with B you have not. It means the input B is going through an inverter to get not B. Once it is not B, now you can simply put both of these inputs through an AND gate. So this is your AND gate, and this is going to be your final output. This is how you have to make the circuit. Just see the input values. First input is going as it is into the AND gate. The other input is going through an inverter. So first put an inverter on the path of B, the second input. Then you will get not B. And after getting not B, you can simply pass it through an AND gate that is connecting both of these inputs. That's it. Now quickly moving towards the second truth table to make it more clear for you. Okay, so here we go. This is the second or part B of example number 4. Here again, first you have to make a logic expression and then the truth table. So for the logic expression, step number 1 says that you have to consider only those rows where the outputs are 1. So look at this. Here the output is 1, here the output is 1. This is going to be row 1 that we are considering. This is row 2. So first, let's work for row 1. For row 1, the value of A is 0 and the value of B is 1. So A will be written as not A and B will be written as it is. And these two inputs will be connected through AND gate. So write an AND in between these two inputs. This is for row 1. Now quickly do for row 2. In row 2, you have A and B, both values are 1. So no need to have not gate, B. It's not A, it's B equals to 1. So just put A and B as it is and put an AND gate. Remember to put an AND gate in every row that you are working. Okay. So it's an AND gate between A, B for row number 2. Now, these are the two rows that we have to consider. Now, what you will be doing, you will join both of these expressions, row 1 and row 2. You have to combine both the expressions with a OR gate. This is also something called a law. It's a law or it's a standard that you have to follow. It's a step. This step is only followed when you have more than one rows that has a 1 in their output. Look at this. If there are 2 rows or more than 2 rows that has 1 output only, this step will be followed in that case. This step says that both of these expressions, like the first expression is for row 1, let me just write it for you. All of the rows that you are working with, row 1 will be OR with row 2. And if there are more than 2 rows that has output 2, output 1, then you will say that Row 3 will also be OR with this. So this is, it depends on how many rows has 1 as the output. Now for row 1 and row 2, just put the values or put the expressions that we have already worked. For row 1, the expression is not A and B. Remember to put a bracket. Then you have OR gate. Then row 2 is A and B. These brackets are going to help you to make your logic circuit. So this is done. This is for your this truth table. You have made the logic expression. It's the final expression. Now what you will be doing, let's make a logic circuit out of this expression. Let's quickly do the logic circuit. So in the logic circuit, what you have to see, first you have to solve the brackets. The first bracket says that the inputs will go like this. If it is A and it is B, so what you will be doing, A will go with a not, means you have to invert the value and then pass it to make it not A. And then B is going directly through an AND gate like this. And let's say that if it is P, the output is P. Okay, this is done for our row 1. Let's make it for row 2 and then we will combine both of them. For row 2, it is simply A and B. A and B means A and B will go through an AND gate directly. A, B. Now we need to combine both of these circuits, row 1 or row 2. This is what you have to do. So let's do it. It's A, B. A is going through an inverter to an AND gate. B is going directly. Let me just write it over here. Okay. And then for the second AND gate, B is going directly and A is also going directly. So it is no need to make too many A and B's. Only one A and one B will be done or made in case when you are joining the both rows, row 1 and row 2, or both the circuits. So this is P and this is, let's suppose, Q. Now remember that you have to join both of these circuits with a OR gate. Look at your expression. Now this OR will be taking P and Q as its inputs and will give the final output, which is X. So here we go. This is your NOT gate. NOT gate helps you to invert the value of A. It becomes here A bar. And then here it is B going directly into the AND gate. This is your AND gate. Then the next one is also your AND gate, which is taking A as it is. This A is going as it is over here and this B from here. So it's going like this and it's giving AND, passing through AND gate and giving us Q output. Then P and Q will be joined. The outputs of both the AND gates will go to the OR gate to give us final result. This is how you make the circuit out of a logic expression. Hopefully everything is clear to you. In case if you have any difficulty in understanding, please comment below so I can answer you. Stay tuned, stay connected, and do not forget to subscribe the channel. Bye-bye.